I was at the Biotic Pump conference in March or April this year, and there were people from all over the world who support this theory that had flown in, and they were talking about this exact tension, the fact that these sort of usurping physicists had come in and had a new theory for atmospheric science, which would mean that everything else had to be sort of looked at and be explained. And they thought that that was maybe some of the resistance to accepting the biotic pump. But I think it's a really, really interesting theory. It's, to me, intuitively explains a lot of things. And I know that we shouldn't base everything off of our gut instinct. I understand that that is not science to everybody listening. But the more that I do this work and speak to scientists from all around the world, the more that things that are intuitive do actually seem to come together to make a big picture of the world.
Welcome to the Manga Bay Newscast. I'm your co-host, Mike DiGirolamo.
And I'm your co-host, Rachel Donald.
Bring you weekly conversations with experts, authors, scientists, and activists working on the front lines of conservation, shining a light on some of the most pressing issues facing our planet and holding people in power to account. This podcast is edited on Gadigal land. Today's guest on the newscast is theoretical physicist Anastassia Makarieva. Along with Viktor Gorshkov, Makarieva developed what is known as the biotic pump theory. The science behind the theory is notable for flipping the script of traditional thinking in meteorology and the hydrological effects of forests on weather patterns and river systems. In this conversation with co-host Rachel Donald, Makarieva details the science and why she thinks forests themselves are responsible for creating not only rain, but also wind, a theory that could explain phenomena such as the cold Amazon paradox and others. If correct, the implications this has for climate modeling are significant. Though still controversial, many in the scientific community believe it needs further research, investigation, and consideration. One thing that isn't controversial, though, the theory highlights, is the complexity of natural ecosystems. There is no shortage of evidence that destroying forests puts humans and wildlife in peril. But there are possibly even more dangerous implications for water supply and climate change than previously realized.
Anastassia, welcome to the show. It's a real pleasure to have you.
Thank you, Rachel. My pleasure.
So you are here today to discuss the biotic pump, this really, really fascinating theory that describes the relationships between our forests and our water systems, and how that relates to global heating. But before we go into that, perhaps you could paint a picture of what is the current mainstream science on the relationship between our forests and our waterways.
The mainstream science is, it depends on which science you mean. Because there is hydrology and there is meteorology. And if we talk about hydrology, then there is a popular opinion, I would say, that when we deforest, we get more runoff. So more stream flow. And if we think in the reverse, if we reforest or restore the forest, then we get less stream flow. And so this could be detrimental for the water cycle and compete with human water use. And here the biotic pump differs in that it says that actually when we have natural forest and sufficiently big, so it actually enhances atmospheric moisture transport and enhances the stream flow. So that's the difference. And that's why it provides a more positive scenario for restoration, for eco-restoration. And also it says that, of course, we need to preserve natural forests as much as we can as the guarantee for the water flow that we have.
So that's quite interesting then, because it's possible to frame the theory that you were saying before as almost human beings and forests being in competition, in a sense, for our waters. The fact that reforesting actually would decrease our streams and we need more waters, and so there's an argument to deforest. But what the biotic pump is saying is that our forests manage the controls of waterways throughout the world. Yes?
in terms of competition, when we have, say, the Amazon River normally, right? It is so mighty, there is so much water flowing that they can hardly be a competition, right? So when we have a desert, there are no rivers, and so nothing to speak about. But when we have this border case, when there is water, but there is not enough water, it is there that this dilemma arises. What happens if we regreen the area? What happens to the scarce and irregular water flow that we have? And why this? Where does this idea come from that the stream flow will decline? Because when you put more plants, they begin to transpire. So the water molecules that without plants would just go along the river, they are now evaporated back to the atmosphere. So naturally the river flow declines. If, and that's if is important, if when we bring in the plants, the rainfall doesn't increase. Because the rainfall is what originally brings this water. So if we have the rain, like the rain is constant, and we put plants and they bring water back to the vapor phase, then there is less liquid water and less stream flow. As simple as that. Okay?
Mm-hmm.
So if you have a cup with water, you can either like pour out water somewhere, or you can wait until it evaporates. So, and the more it evaporates, the less you can drink or something like this. But what the biotic pump is about is where this water come from in the first place. So how it arrives by the atmosphere and makes rains. And the biotic pump describes the change of the atmospheric dynamics that happens when we add natural ecosystems to this picture. So basically what we are saying is that there will be more moisture arriving through the atmosphere, more precipitation that will enhance the stream flow, even though the evapotranspiration will also increase. So there will be even more surplus. So, and this is something that is not very straightforward, because you really need to consider these dynamics, and that the atmospheric dynamics will change when we add the ecosystem into the picture.
So I think we should try and describe some of the amazing, graphics that you and your colleagues have made over the years, because we are talking about a pump. So, the forests in the middle of the Amazon, very, very, very far away from the ocean, are through these atmospheric dynamics pumping water vapor from the ocean in order to fall over them and then be evaporated again. Is that correct? Am I describing that correctly?
Yes. So when we have the forest, and it keeps the atmosphere moist such that there is condensation ongoing. So this brings more moist air from the surrounding areas, and this enhances moisture import, which in the steady state is equal to export, which is the stream flow. Right? The stream flow is what the ecosystem, how much water it dispatches of, right?
Mm-hmm.
So the import is via the atmosphere, the export is through the channel, through the river, in the liquid form. And the forest increases this atmospheric inflow, and so the stream flow also.
And so this is amazing, because essentially these ecosystems are functioning in order to provide themselves with the moisture that they need. And this is part of the biotic pumps theory as well, as to why there's very little rain in the desert. It's the fact that there's not a lot of vegetation, right?
Yes, it is. So in principle, there is a different state possible if we could bring back the vegetation that once thrived in the desert. So possibly we could restart a more active water cycle. But what's important is that there are tipping points. And this is what we were doing more recently. Like last year, we were investigating these tipping points. Because what is important? Important is that when the forest invests its moisture via evapotranspiration, it is like an investment, because the forest has a moisture store in soil and it transpires, it gives it back to the atmosphere, so it loses it from soil, right? So it must have more in return than it has spent. And this, to get more, there must be condensation and the pressure drop and all the dynamics that will bring more moisture in. But imagine that it has invested while the atmosphere is so dry that no condensation happened. So it's just transpired into a dry atmosphere, but nothing happened. And so then it will just wait until the wind will blow all this moisture away, and the moisture will be lost. And it will lose, so it will get drier, and then it will lose even more if the transpiration continues. So and in this way, the ecosystem can switch to a much more arid state. So it's important to transpire into a sufficiently wet atmosphere and to keep it moist, to keep it stably moist. And when we deforest, for example, and what does it mean, moist? It means that the relative humidity should be high, right? Such that the dew point is close. When we cut the forest and even the absolute humidity is the same, but temperature rises, so relative humidity declines, and then condensation doesn't occur, and so there is a loss of moisture by evaporation, and there is more and more aridity. So we can just kickstart this process of aridification by destroying the forest. And because of that, it is not easy to bring the ecosystem back. Because when you have a dry state and you come there and put a small green thing and it begins to transpire, but nothing happens because it's too weak, the atmosphere is too dry. So you really will need a massive effort, or you would need to find the wet spot, the place where the chances are the highest that these small things that are recovering will at a certain point will be able to change the dynamics. So, and in this sense, in this dry situation, the traditional picture is correct, because when you plant eucalyptus in the desert, it just takes water from the groundwater store and transpires and nothing happens. So it really can decrease the water level, decrease the stream flow, because there is no condensation and the biotic pump is not working. So this tipping point emphasizes the importance of maintaining natural ecosystems that have evolved to master these backs in such a manner that the water cycle is both intense and more or less stable or uniform.
Hey, it's me again. Just another quick note. Thank you so much for listening to this podcast. We really appreciate it and your support of this show. We couldn't do the deep dive audio reporting we're doing on some of the world's biggest environmental issues without you listening to it. I have a small request for you. If you're currently listening to us on your browser, like Google Chrome, we highly recommend you subscribe to us through the podcast provider of your choice, because that helps support our show further, raises its profile, and brings us to a wider audience. And it's also the best way for you to stay up to date on new shows we release and catch up on our previous episodes. And if you're really enjoying this podcast and want to support us further, share this episode with a friend and spread the word about the Manga Bay newscast. Thank you so much for listening. And now, back to the conversation.
To me, this is what is so exciting about the biotic pump as a theory, is the sort of exponentially positive impact of reforestation. So looking beyond the fact that it's good to restore our ecosystems for, biodiversity or as carbon sequestration, and there's a huge amount of focus on carbon with regards to the climate crisis. But the fact that restoring these forests around the world then has this positive impact on our waterways, which then will help the reforestation process. It's a positive feedback loop in both senses of the word, which is so important. I mean, we need to be able to have these systems that we can deploy that are superlinearly or exponentially positive, given the amount of ecosystem destruction that's gone on around the world. And I would love for you to speak to what the biotic pump suggests as well about the levels of CO2 in the atmosphere and the impact then on global heating, and how if we continue to destroy our ecosystems, we might actually feel more of the effects of heating with the same level of CO2 in the atmosphere as we would if we restored our ecosystems.
This is a related and important point, but it is not even very specifically about the biotic pump, but more generally about the climate regulating function of natural ecosystems. So what we know about natural ecosystems is that they are very powerful. In which sense? First of all, their primary productivity is 10 times more than how much carbon we use in this civilization. So we use around, the fossil fuel emissions are about 10 gigatons per year of carbon. Meanwhile, the biosphere cycles 100 gigatons of carbon per year. And so that shows the power of any imbalance in its functioning. So whenever there is imbalance, it would impact very strongly on the atmospheric composition. So also what we do know is the very important impact that the natural ecosystems have on clouds. This is a very active area of research, and we do know that clouds, many types of clouds that cool the earth, they prefer green surfaces, especially forests. So we are learning more and more about that. And it means, and we also know that trees and other, not just trees, but all organisms in the ecosystem, including even bacteria and fungi, can produce specific biochemical compounds that facilitate cloud formation, right? So biogenic compounds that facilitate cloud formation. And we also know that the production of such compounds grows with increasing temperature. So basically, we do know that ecosystems can respond to warming with producing clouds that cool. And then the question is, if the ecosystem can do that, how the evolution would guide, how the evolution would shape this ability? Apparently, if there is optimum temperature at which the ecosystem can exist, and it is physically possible to regulate this optimal temperature with clouds, then the evolution will favor such an ability in the ecosystems. And so, when we have a healthy biosphere and the natural ecosystem occupies sufficiently big area, we can expect this stabilizing impact via regulation of the cloud cover, providing the water cycle is under biotic control and the biotic pumps works and all that. Then the ecosystems can produce these cooling clouds when it is too warm. Okay? And now imagine we have a healthy biosphere, untouched, purely virgin, pristine, and we begin to add CO2 to the atmosphere, a hypothetical situation. Then all these ecosystems will employ their evolutionary capacity to regulate the temperature, will produce compensatory clouds, and the warming that will occur, it should occur, as we know from physics, but it will be partially compensated, or even for the major part, compensated by this response. Now, imagine that we begin to destroy, in addition to adding CO2, we are destroying the ecosystems that were buffering warming from CO2 via regulation of the cloud cover. What will happen? The sensitivity, which means the temperature response to each CO2 molecule added, will grow. So basically, if with a healthy biosphere, just hypothetical numbers, we would have like 1 degree warming per CO2 doubling compared to pre-industrial state, then when we fully destroy the biosphere, we would have like 3 or 4 degrees. So, and it is also important that clouds are a major source of uncertainty in climate models. So basically, it is difficult to say how they will behave, and how their many biotic effects are not still known, are not taken into account. But we can see that as the models improve the representation of the cloud cover, especially in the latest generation of climate models, they show increased sensitivity, so a greater response to CO2. So models that better describe the cloud cover, that have been calibrated with the newly available data, like from satellites, they show high sensitivity, which actually is a problem now in climate science. The scientists even try to exclude them from to downgrade their impact on the scenarios that are considered by policymakers, because they think that they are unrealistic. But this high sensitivity in the most sophisticated models describing clouds could be a representation of the growing sensitivity to CO2 that is happening due to the continued loss of natural ecosystems, and especially in the tropics, the Amazon, Indonesia, and Africa, equatorial Africa. So, and these models just unknowingly calibrating the reality, they mimic this process. And so they yield this high sensitivity. So this could be a dangerous signal that we are seeing something that we don't fully understand. And this can be the representation of this second major process that is reshaping the face of the earth, which is the loss of primary ecosystems of forests and also ocean. So when we disturb the ocean, of course, oceanic biota also has an impact on cloud formation. So these are very complicated processes going there. So we disturbing the ocean further and further, and the cloud cover changes. So, but I must say that this is what I'm telling you. This is a complete heresy. Like if you think about the mainstream climate science, so because people have difficulty in appreciating this idea that natural ecosystems provide a stabilizing impact. That this is the bottom line. Simply because otherwise, if they can do that, if the physical laws allow them to do this control, and we do know that they can control clouds, so of course then the evolution would favor such regulation. But this is difficult for people to accept, because it is something that we don't see in the yard. Something. It is actually these are generalizations that only became possible when the science, environmental science, became as sophisticated as it is now, and so that we know a lot about how these ecosystems function. So our concepts are lagging behind the data. We still think in outdated terms, just seeing ecosystems as passive object just affected by climate change, rather than, for example, compensating or buffering climate change.
I mean, I would love to get your opinion on why that is hearsay. More like is it because boiling climate change down to a problem of CO2 allows for a kind of like market response or industry response or a policy response that, whether or not it's being done, is actually quite simple? Reduce that and things can continue as they are. Whereas when we factor in natural ecosystems, which by their very nature are complex ecosystems, the problem as well and the solution become more complex. Do you think that there's been a sort of this political resistance to acknowledging the fact that our natural systems, our ecosystems are so important that maybe we cannot continue extracting from them?
Yes, I see what you ask about. I've been thinking about that. And I would say that now the policies, or at least declared policies, very accurately reflect the message from the science, from the IPCC science. So I would say that the problem is in how the science historically developed when the biosphere was added at a later stage, and in how the community is structured, in that there is no how, for example, how are the models, how the uncertainty of the models is judged. There are several centers in the world, like a few dozens, and each of them develops their own model. How they are related, of course, because people exchange, but what determines how the model is developed is like nobody knows. Just how they calibrate it, what kind of parameterization they use. And then all these models are pulled together. They generate different predictions, and this variability is judged as the uncertainty. But as the nature is out, like it is, there is no incentive to change it. So how I would do that? Instead of just, spontaneously develop these models, nobody knows in which direction. And then when something pops up like these hot models with high sensitivity, then we will say, oh no, they don't fit our expectations, even though people were developing them and hoping to improve them, and they did improve them. And thus, an absolutely different approach would be, let us start from the premise that natural ecosystems regulate climate via clouds. Okay? And then let us try to develop a model that incorporates this premise. And then we will see whether the uncertainties that are around, that are acknowledged, can accommodate such a model, such a possibility. So we have an alternative idea, a concept, and our goal is to see where it can be put at the heart of a climate model, and whether such a model can be competitive with respect to others. So instead of trying to narrow uncertainty and pushing away everything that doesn't fit to our previously formed expectations, let us do the opposite. Like many IT companies, what they are doing, they're promising money for those people who will reveal an error in the code, what they call vulnerability. So because they want security. So in order to ensure maximum security, they deliberately incentivize people to look for vulnerabilities in the code, for errors, for how to destroy it. And this is what we are missing in the current climate enterprise. We are not disrupting, not trying to maximize this security. Actually, there should be an incubator of people who are trying to provide alternative ideas just to see whether it works or not. Because imagine that these ecosystems that we are losing them, and we only think about them in terms of carbon, like carbon accounting, and we can only see what we conceptualize. So if we are totally abiotic, we won't see that. So I would propose such an initiative. I have been proposing it already for 2 years. Just let us be disruptive and try to see let us push the uncertainties as high, as far as possible, rather than pretending that they are small. Encourage that. But this also has to do with the social issues of the science, and these are considered in social science literature, that there is research showing that big scientific enterprises are good for incremental science. So for going along the clear path, paved path. But small groups are good at providing disruptive insights. So if we centralize science, and if there's basically one uniform community and also the grant system, which you will never get a grant if you are not in the system, then we are losing this disruptiveness, and we are losing it. So I would say that we do need this endeavor of a climate model that incorporates biotic response as the core.
Excellent. And just out of curiosity, how long would it take to build a model like that?
We should understand that the models that are developed right now, they're very sophisticated with lots of people working there. So we would need to go back to start from something more simple and just to check the first order effect, whether it is at all possible. This is very simple. Let us hypothesize a certain strength of the cloud feedback. We don't basically know very little about clouds before the satellite era, but we can make reasonable guesses. And let us see whether, if we think that natural ecosystems provide this feedback, disturbed ecosystems don't, can we have a meaningful account of the data, of the so that's it. It's not very demanding. It's just a matter of dedication.
Well, Anastassia, I mean, it's also fascinating. And if we had more time as well, we'd go into, and in fact, I'm inviting you back on at some point in the future to discuss the story of how the biotic pump theory was created as well, because it really is astonishing. It is, exactly as you said, a small group, two of you, who have created this disruption in atmospheric sciences that certainly, to me at least, as a science journalist, reveals something quite intuitive, which is that our ecosystems, of course, are connected into larger systems. And certainly the fact that the reports of our ocean temperature are literally off the charts and that warming is increasing faster than what the IPCC report predicted for our current pathway, then it would suggest that there are other factors in play, perhaps exactly as you're saying, cloud cover, for example, that could explain why it is that we are seeing worse effects than were sort of predicted by science only a year or two ago.
Another recognized cause of temperature changes are also the change of atmospheric circulation. So when we disturb vegetation on a big area, so this also changes air circulation, and this can translate to global warming, just because when heat is transported around the planet, it matters for the global temperature where it is released from space. Like the very basic example, if we get a current of warm air from equator to the pole, then this heat will be radiated to space at the pole where it is cold and less water vapor and greenhouse effect is small. So a lot of heat will just escape and global temperature will be lower. If we stop this circulation, then heat will remain, say, at the equator, and it will go to space through this warm tropical atmosphere full of greenhouse absorbers, and this will impact global temperature. So also when we disrupt atmospheric and also oceanic motions, this also can lead to unpredicted responses. And in this sense, why also biotic pump is, as you see, disruptive, because if we accept that vegetation changes and natural ecosystem changes air circulation, then land cover change becomes a driver of climate change, just because of this impact on temperature. So it is not a response to CO2, but it is an independent driver of climate change. And because of very large uncertainties associated with air circulation, with precipitation, with oceanic circulation, it would be just like opening Pandora box. CO2 is a very complicated problem, but it is easy in that sense that there is CO2, it is well mixed, and so like doable. So having CO2 as the driver is comfortable. If it turns out that land use is a driver of climate change through changes in air circulation, the complexity rises exponentially. So that's why I would say that's why there is a resistance to this in the community.
Yes.
It is very complicated.
Yeah. It makes sense, I think, especially when also we consider the political will, the desire, obviously, to find solutions that allow the perpetuation of the status quo, which is essentially fundamentally the extraction of natural resources in order to generate wealth. And once you place natural ecosystems within this theory in their rightful place as these incredible systems of management, essentially, and balance and stability, then it throws our entire sort of human civilization into question and necessitates a fundamental change in how we organize and how we relate to the planet.
Yes, and what is important is that it is the first time in human history that we are at such a point. Because really, we were totally illiterate about how the biosphere works for all our history. like all these civilizations, great civilizations that existed, they only took from nature, and they were local, and there were local disasters, and it continued. But now we have this planetary overview of what is happening. So it is, I think that we will, if there is no rapid collapse anytime soon, and our concepts will mature. Now they are not adequate to the richness of data that we have. So we're still thinking about the biosphere in very, very primitive terms.
Well, not for long, hopefully. Anastassia, I'm conscious of time, so I just want to say thank you very, very much for your time today, and for the work that you're doing. We will direct people where they can read more about the Biotic pump. And yeah, good luck with continuing to be disruptive.
Oh, thank you very much, Rachel. Same to you.
So, the biotic pump theory. The first thing I would like to start with talking with you about, Rachel, is the controversy surrounding the theory, because I think it's important to address that. So, for audience members that aren't aware, this theory was submitted to a very high-profile journal in a paper, and it was recommended for rejection by one reviewer, and then there was almost 3 years of debate about it, and another reviewer recommended it. And the journal went ahead and decided to go ahead and publish it. And that journal was Atmospheric Chemistry and Physics. And the title of the paper was Where Do Winds Come From? So it still hasn't been, latest news I've read on it still says that it still hasn't been, validated or disproven, as it is still considered a theory. But there was strong scientific opinionating that its inclusion and discussion needs to be talked about and looked at and understood more and tested. And it could explain a ton of phenomena that, happens specifically in like tropical rainforests like the Amazon and the Congo Basin. That was just some context I wanted to get out of the way there, but Rachel, take it from here.
Thank you for providing that context. I did think when I was preparing to interview Anastassia whether or not I would bring that up to discuss it, but we just don't have the time. Like the controversy around the theory would almost take as long to explain as the theory in detail, because the story really, really goes back and forth. But it is important, and I think it's one of those really interesting moments in science where how is it that we establish truth when our creation of truth is built on consensus and built on prevailing wisdom. Mm-hmm. And we all know that certain science breaks the mold, breaks the norm, usurps prevailing wisdom essentially, and that's how we make breakthroughs. It's how we have our eureka moments. So it's been a very interesting challenge for these scientists who are involved in the biotic pump, and we shall see what comes out of it. I know there's interest in sort of writing books around that context in itself, as you've just laid out. There's a couple of things around it actually that I just want to state. So number one is that Anastassia and Viktor Gorshkov, who sort of developed this theory together, she was his student for a long time and he is unfortunately dead now, were physicists. And this theory of the biotic pump kind of falls under atmospheric science. And I think that's been one of the interesting tensions as well, because it totally usurps the prevailing wisdom of atmospheric science as to how these water cycles and wind cycles are made, essentially, how the atmosphere acts. And so when I was at the Biotic Pump conference in March or April this year, and there were people from all over the world who support this theory that had flown in to discuss it, and they were talking about this exact tension, the fact that these sort of usurping physicists had come in and had a new theory for atmospheric science, which would mean that everything else had to be sort of looked at and be explained. And they thought that was maybe some of the resistance to accepting the biotic pump. But I think it's a really, really interesting theory. It's, to me, intuitively explains a lot of things. And I know that we shouldn't base everything off of our gut instinct. I understand that is not science to everybody listening. But the more that I do this work and speak to scientists from all around the world, the more that things that are intuitive do actually seem to come together to make a big picture of the world. So why is it that loads and loads and loads of rain falls on the Amazon, and where does that water come from? And it seems that the forest actually helps create the water cycle that then perpetuates itself and is part of this like global holistic system of management of the Earth's most important resource, water. Yeah, that makes sense to me. How about you?
Yeah, actually, that's the thing, is that a lot of phenomena could be explained by this theory. There's a great summary of this whole debate and the evidence and such on science.org that sort of lays out the whole story of how this, was developed and all the various implications. But one interesting facet of this is that the theory could help explain like freshwater supply. I don't want to misquote the article exactly, but the one on the science.org, I believe, mentioned that there was a study done that showed that it was done by a scientist named Ruud van der Ent.
Great name.
And who put this into a global model of airborne moisture flow. And through this, they found globally that 40% of all precipitation comes from the land rather than the ocean.
Wow.
And in China gets 80% of its water from the west via forests of Scandinavia and Russia. And so,
Amazing.
China is a giant country. So and just as you explained, Rachel, the biotic pump theory sort of flips the traditional thinking on its head, where it's not the atmospheric circulation driving the hydrological cycle, but the hydrological cycle driving the circulation of the air. So that's part of that theory there. Again, not a scientist either, and I agree with the people that say that this needs to be tested. Mm-hmm. The latest information I see shows that it hasn't really been tested yet. So it definitely needs to be, in my opinion. And I don't see any reason why not to consider it, or at least think about it in terms of how we look at the impacts of losing tropical rainforests or just forests in general.
I am so glad you brought that up, because to me, this theory is such an amazing political tool for a holistic understanding of our ecosystem services. Like, water is the most important resource on the planet. Kamala Harris, a couple of months into her vice presidency, Kamala Harris said in the future, wars will be fought over water, as she was walking away from a podium and was still mic'd up, essentially. It is absolutely critical. And so to understand that our forests are key to protecting the supply of this resource at a time when forests are being cut down in order to avoid wildfires because of increasing warming temperatures and climate change. Yeah. It's really, really important. And I think as well, politically, then it becomes a really interesting question of understanding that, like, okay, well, our water is supplied by your forests. And so actually this global crisis isn't a question of territory and boundaries. It's a question of, holistic management and global cooperation.
I'm glad you brought that up, because unless I've been sleeping under a rock, I believe that Egypt, Sudan, and Ethiopia are still negotiating their deal on sharing the waters from the Nile, right? And a scientist named David Ellison, and again, I got this information from science.org, a scientist named David Ellison suggested that basically the Congo Basin rainforest is supplying there's a study showing that much of that, the rainfall from the Congo Basin, is supplying the water for the Nile River. So what happens if that gets deforested? Mm-hmm. You will probably, at least indicated by the study, see less water for these three nations that are negotiating a deal on sharing those waters. Mm-hmm. It's a big problem to consider.
Yeah, definitely. And I just like these pieces of information that are a microcosm of the big picture.
Right.
You know, being able to say this plus this, this impacts this globally. Like these things are so intertwined that we cannot unmake them or undo them. And doing so, like understanding that takes a sort of feat of a jump in our sort of scientific thinking, and then also managing it demands a jump in our political thinking. This is, to me, this is all, it's the future. To me, it's the future, and it makes it a very, very exciting theory. Obviously, it still needs to be tested, but it makes it a very, very exciting thing to be approaching. I mean, in a world where our ecosystems are under such attack, both from the crisis and from our economies and from our politics, to be able to frame things as interdependent, and thus our political goals as interdependent. I keep saying it, but it's very, very exciting. And I hope that these are the pieces that keep coming through as we move forward.
Yeah. You've already said it, so I don't need to reiterate it further. I just think that the evidence that protecting forests, not that we need it anymore necessarily, but the evidence that protecting forests or using them in an unsustainable, exploitative manner is doing us no favors and is really, really going to mess things up way more than they already have been. And policy that isn't directed at protecting all of that with every might that we can muster is not great.
Yeah. I think it's going to become a question of protecting forests becomes a question of protecting national and international security. If people really begin to understand the role that they play in managing all other ecosystems, i.e. all other resources, then I hope soon that the script will be flipped. And I really hope that soon they will be understood as a resource for protecting all life rather than just a resource of steady timber supply.
Agreed. Well, I think listeners should give this one a deep dive, look into it, check out the biotic pump theory, and see what you think, and share this episode with others.
And please do.
Thanks, Rachel.
Thanks so much, Mike.
If you want to read more on the biotic pump theory, resources are available in the show notes. As always, if you're enjoying the Manga Bay newscast or any of our podcast content like our sister series Manga Bay Explores, and you want to help us out, we encourage you to spread the word about the work we're doing by telling a friend. Word of mouth is definitely the best way to help expand our reach. But as always, you can support us by becoming a monthly sponsor via our Patreon page at patreon.com/mangabay. We are a non-profit news outlet, so really just $1 per month makes a big difference, and it helps us offset production costs. So if you're a fan of our audio reporting from Nature's Frontline, go to patreon.com/mangabay to learn more and support the Manga Bay newscast and all of our podcast content. You and your friends can join the listeners who have downloaded the Manga Bay newscast over 500,000 times by subscribing to this podcast wherever you get your podcasts from, or you can download our app for Apple and Android devices. Just search either app store for the Manga Bay Newscast app to gain fingertip access to new shows and all of our previous episodes. If you happen to listen to this episode on a browser, I still encourage you to subscribe to it wherever you get your podcasts from. But you can also read our news and inspiration from Nature's Frontline at mangabay.com, or you can follow us on social media, find Manga Bay on all of our social media accounts at LinkedIn at Manga Bay News, or on Instagram, Threads, Blue Sky, Mastodon, Facebook, and TikTok, where our handle is at Manga Bay, or on YouTube at Manga Bay TV. Thank you, as always, for listening.